Welcome back onto our next transformation. That's a translation. So a translation is a slide isometry. So remember, isometry means that it does not change size or shape. So here we have A, B, C, D, E is the pre-image. A prime, B prime, C prime, D prime, E prime is the image. The prime marks tell us that that's the image. Notice the orientation is the same. Right? In this case, the letters are going counterclockwise on the original, the pre-image, as well as the image. And the vector is used to show the magnitude and direction of the translation. Right? So the vector follows the arrow. Right? So it starts at the pre-image. And eventually that will write. Any day now. Well, as soon as that stops, I'm going to write it. It starts at E and it ends at E prime. That's a really long time for that to keep going. There we go. This doesn't want to seem to let me write. There we go. Starts, ends. There we go. Now the board will behave. Maybe it just takes them a little while to wake up. Yeah. So we're going to draw the image after the translation. And now I can cheat a little bit because I have it right here. Okay. So you're going to follow along your notes. Some of them are in here. I don't believe this one is. And there goes our figure. Right? And so for the translation, it's going to slide from the start of the pre-image to the end of the pre-image. Excuse me, to the ending spot. Right? So let's mark our coordinates, our vertices. So this would be E prime, this would be D prime, C prime, B prime, A prime, and F prime. Right? So there is, that vector there shows the movement of our pre-image. All right, let's look at the next one. Right, so we want to draw the image after the translation. Right, so the vector here, as well as my little extra line. This one's the vector showing. And actually there'd be a vector for each one of these points. Right? But the vector shows the movement, the magnitude, and the direction of the movement. Right? And so if I have A, B here on my pre-image, I'm going to have A prime, B prime on the image. So the corresponding points on the original and the image need to match. All points on the original need to move the exact same distance. Right? So here our figures are moving a distance. And actually I think you had, not this one, but I think you're going to have, yeah, not this one, but you have, in your notes you have one that's coming up. But I already did them. It's already drawn for you. All right, so translations. All right, so in mathematics, the translation of an object is called its image. If the original object was labeled with letters such as polygon A, B, C, D, E, the image may be labeled with the same letters, followed by a prime symbol. So A prime, B prime, C prime, D prime, E prime. All right, so we know that the pre-image, the original, will have no mark, will just have the letters. And the image will have the symbols on it. And if we did another transformation, right, then it would have two prime marks. Right, so a translation slides an object a fixed distance in a given direction. And these are all in your notes. Properties preserved under a translation. Distance, lengths of segments are the same. Angle measures remain the same. Parallelism, so parallel lines remain parallel. Collinearity, points stay on the same lines. Midpoints remain the same in each figure. The orientation, the lettering order remains the same. The perimeter and area do not change. So all of our transformations that are isometries, the size, the perimeter, area, that is not going to change. The only properties that are changed under a translation is position. Okay? It's in a new location. So the x and y coordinates are going to change, but that's it. Now I should say x and or y. So the image is going to be congruent and the letters are going to all face in the same direction. It's just going to be in a new position. Right, so a little bit about vectors. So this is a vector, right? Not an arrow, it's a vector. And a vector has magnitude, how long it is, and direction. And I don't see that initially in your notes, so at the bottom there, I want you to add this to your notes, right? And you can also add the little picture there as well, all right? So just put this part in your notes. I don't initially see that. Not unless it's on the next page, and that's a little bit, but we can still add that. And waiting for my page to change. All right, so this is in the next thing in your notes. All right, so a translation is a transformation, and this is on the next page. So I've skipped a little part in your notes, probably because it didn't fit. So a translation is a transformation along a vector such that each segment joining a point and its image has the same length as the vector and is parallel to the vector. Right? So our vectors here are going to show us our movement. Right? So we're moving along a vector. Right? So each segment joining a point in its image is going to, all the vectors are going to be the exact same length because all the vectors are moving the same direction. Right? A little bit, let's label your diagram that you have in your notes. Right? So A prime, B prime, C prime, those are all vectors, right? And they're all going to have the same length because every figure moves the same distance. Right? In your notes, I want you to write that vectors are finite, which is the opposite of infinite. Right? They're moving a specified distance. The first point there, that's your starting point. It's kind of like a ray, right? Only we called it on a ray, we called it an endpoint. And then the tip of the arrow is called an endpoint. So vectors are not infinite like rays. Right? So that arrow doesn't mean it's going to keep on going. Right? For vectors, where the arrow is where it stops. So it's a little bit different. Notice it's labeled different. Right? So V here, notice the arrow, it's not a two-sided arrow, it's only there's only one little part of the arrow. Right? So it's like half an arrow. Right? So that's indicating that's a vector. Right? So vector V. Right? So vectors are not like rays, they are not infinite, they stop. They're finite. A vector has direction and magnitude. So magnitude is has the same meaning as length. Right? We'll put that in parentheses. We don't call it length, however, we call it magnitude. But just to help you understand, to translate our objects, our figures. Right, so translation occurs along a given vector. A little part of this is in your notes, the top part. One of its two endpoints is known as a starting point, while the other is known simply as the endpoint. A little different than a ray. A ray's starting point is called endpoint because it doesn't stop on the other side. But a vector does. The length of a vector is by definition the length of its underlying segment. Pictorially note the starting and ending points. So I do have a little note here for you to put this in your notes. Right? So here we have vector AB. Vector AB starts at A, ends at B. Next to it we have vector BA. Right? So vector BA, we start at B now and end at A. Right? And that matters. On a line segment that wouldn't matter, right? Because we're just looking at that distance between the 2 points there. For a vector it does matter because vectors signify movement. Right? So vector, if we're translating using vector AB, we're going in a different direction than if we're translating using vector BA. Same magnitude, but not the same direction. So a translation of a plane along a given vector is a basic rigid motion of a plane. When we see rigid, if we say a rigid transformation, that means the size isn't changing. Okay? It's like it's staying the exact same size. Three basic properties of a translation are: the translation maps a line to a line, a ray to a ray, a segment to a segment, an angle to an angle. A translation preserves lengths of segments. A translation preserves degrees of angles. And a translation is a type of isometry. Okay? And a lot of this is already in your notes, maybe not in that exact spot, but in a different place. Right? But I do want you to put in the pictorial representation of the vectors. And you can pause me to do that. And when you come back to me, we'll be on the next figure. All right, so this one is in your notes. A translation is a motion of a plane that moves every point of the plane a specified distance in a specified direction along a straight line. Properties of translation: a figure and its image are congruent. The image of a line is going to be parallel to it. Right? So we're going to find the image of AB under the translation from x to x prime pictured on the dot paper. Right? So that means we're going to use this vector. This is the vector. So vectors can be listed with one letter or two. Right? So this is vector x, x, y, or x, x prime, and still has that same symbol for vector. That's like half an arrow. Right? So I'm going to move the points on AB the same distance and the same direction as the vector here. So notice they're going diagonally, and they're going diagonally 1, 2, 3 spots. So that means I'm going to move A here 1, 2, 3 spots, and this will be A prime. And I'm going to move B 1, 2, 3 spots. This will be B prime, and then I can connect. All right, so now we've translated AB, and we've moved it to where A prime, B prime is. Notice those lines are still parallel to one another. When we translate, right, the original and the image, the corresponding segments are going to still be parallel to one another. Right? So the vector just shows us the direction and the distance that we're going to move our figure. Right, so here we have this one. You have the second one in your notes. We're going to translate each according to the instructions provided. 2 units down, 3 units to the left. Draw the vector that defines the translation. Right, so every point is going to move 2 units down and 3 units to the left. Right, so this is the vector that defines that translation. Right, so we're going to apply that vector to every single point. I already did that to S. This is where S prime would be. We'll do the same thing to R. Right, so here's where R prime is going to be. Do the same thing to U. Here's where U prime will be. And to T. And here's where T prime will be. Right? So we've moved every point the same distance and quite the same direction. One of these things isn't the same. Sorry, I counted the wrong direction. But with the vectors, I could see that one vector was not parallel to the others, but now it is fixed. All right, so now let's connect our points to draw our image. So there's our image, R prime, S prime, T prime, and these are the vectors that show the movement. And interestingly, now it has turned my square into what looks like a prism. Let's do the same thing with the one that's in your notes, the triangle here. Right? So our vector is 1 unit up, 2 units to the right. Right? So here's our vector. And I've already applied it to D. So there's D prime. We're going to do the same thing to F and to E. Right? So now we've applied the same vector to all 3 points. And now we can also, actually I'm going to do it in a different color so we can see the difference between the vectors and our image. As soon as that goes away, right, so we're connecting D prime, E prime, and F prime, and there's our image, right? So the blue lines, and we'll put this in your notes, are the vectors, and oops, this one's missing. Right, so E prime, F prime, and D prime. We'll write that below. E prime. Come on. I don't have all day. D prime, and f prime. Those are the vectors that we translated the points with. And then the green figure here, this is our image. And this one over here was the pre-image. And there comes the rest of my word. All right. So this is in your notes. We're going to go back a page to this information in your notes. All right, so definition, a translation is a transformation of the plane that slides every figure the same distance in the same direction. And we have several different ways of writing it. I know part of this is on the other page. Oh, actually, it's in two different places. All right, so you're going to have to be turning the page a little bit. Sorry about that. But the first part is right here. So here we have coordinate notation. This is on page 3 of your notes at the very bottom. All right, so let's put a star by that. Coordinate notation. So you need to be able to represent transformations in coordinate notation. And let's put a star over here. Vector notation. All right, so this is in your notes on page 3. My figure didn't fit in, so I squeezed it in on page 2. All right, so let's take a look at the two different things and what they mean. And so we're going to flip pages to page 2 once we get to the vector translations. All right, so coordinate notation. All right, so this is telling you what to do to every x and every y. So we see where we see t, x, y goes to. And then we have x plus 3, y minus 1. What that means is we're going to add 3 to all the x coordinates. We're going to subtract 1 to the y coordinates. And we're going to do that for every single point. Sometimes the t is left off and it's shortened to xy, goes to x plus 3, x minus 1, means the same thing. So the image of the figure is 3 to the right, because that's, whoops, one of us did not plug in her computer. That would be 3 in a positive direction, and 1 down, because that would be in a negative direction. Right? So where we see, we have, and I want you to put this in your notes. You can put this on page 3. We'll keep that all together. All right, so right under that, under that figure there, you'll just put this in your notes, where we have x, and then the arrow, wherever we see a plus, that means we're going to the right. Wherever we see a minus, we're going to the left. For y, that's vertical movement. So if you see a plus, that's up, a minus, that's down. Make sure you put that in your notes. So this is one way. You need to be able to understand coordinate notation. Now you're going to turn your notes over back to page 2. Another way to describe a translation is with a vector. Right? So notice we don't have parentheses here. We have arrowheads. We use the arrowheads for vectors. That's so we don't think that that's the 0.3, negative 1. Instead, that's a vector. The first number is, and this is all in your notes, is horizontal change. That means, in this case, it'd be 3 to the right because it's positive. The second number is vertical change. Since it's negative, it's going down, 1 down. Vectors express movement. So here, when we have a vector of 3, negative 1, we're going to add 3 to x. We're going to subtract 1 from y. All right, so that's the only thing to put in your notes is the very last part on page 2. Okay, so we're going to go back and forth and use both vector notation and coordinate notation. You need to be familiar with both. All right, so a translation is a transformation of the plane that slides every point of the figure the same distance in the same direction. All right, so here what's being translated is the line PQ. Right, so the green line there is PQ. The red line is P prime, oh, that's really straight. P prime, Q prime. And then the orange lines there, those are the vectors. Notice the vectors are parallel. They'll always be parallel because we're moving in the same direction, the same distance. So we can label these as the vectors. And I don't think you have this one in your notes. I have to turn the page. No, you don't have this one in your notes, and that's okay. All right, so here's the two different ways to label this. Right, so, and by the way there, notice a little bit about our vector. So PQ is congruent to P prime Q prime. Right, so our figure is going to maintain the same distance, our pre-image and our image. And then it's also going to be parallel, right? Because parallelism is maintained because it's moved the same direction and the same distance. All right, so here we have it in coordinate notation. XY goes to x plus 4, y minus 2. And then we have it in vector notation. We have the little arrowhead brackets there, and then 4, negative 2. Both of those are saying the same thing. It's telling us to move every point 4 to the right and 2 down. All right? So translation in coordinate plane can be described using coordinate notation, and then we can also use vector notation. And each point is going to shift the same distance horizontally. And so what I add to x, I'm going to shift horizontally. What I add to y, I'm going to shift vertically. Okay? And so xy goes to x plus 4, y minus 2, shifts each point 4 units to the right and 2 units down. I'm going to pick up with this one in the next podcast. We're going to look at a way to notate our transformation using a matrix. Right? So we're going to take the information that we're given from coordinate notation or the vector and use a matrix to keep track of where our figure should go rather than counting. Because sometimes it'll either be difficult to count on that coordinate plane or you may actually move right off the coordinate plane. Right? And so this method, matrices, will give you a way to deal with that no matter how far you move, right? Or even if you're given a coordinate plane. Right? So in the next podcast, we'll be looking at this problem, and then we'll do a few more. All right? So I'll see you in the next podcast. Bye for now. And this one's going to be the first one I think that's in your notes. All right? Bye for now.